Friends, good evening. Today's topic will be RCM, Reliability Centered Maintenance. As this video is mainly related to the people who are in the maintenance manager, engineer, reliability engineer, vibration engineer, whoever is related to the maintenance. And particularly, I would like to talk about the machineries, rotating machineries. What is the importance of the RCM, reliability centered maintenance, and why it should be practiced? Practice in a sense that maybe you are in a working plant or working refinery, already the refinery is going on, or you might be having the commissioning of the refinery. So naturally you need that you should understand the concept of the RCM and the application of the RCM. Reliability centered maintenance actually is a analysis process. For example, if you have a refinery which is running, you might be having in place with you centralized maintenance management system, organization for the maintenance. You might be having the your softwares, vibration management, tools, or many things are there, manpower, trained manpower, everything is established. So I am assuming that you might be having some systems, maintenance systems, where you are already doing the maintenance. But RCM is a project in a sense. It is a beginning and has the end. You might have done earlier, but if already 4 or 5 years happened, then you have to review and see whether whatever the RCM you have done 4 or 5 years, can you do again, and whether you will get the benefit or not. So this video is related to all the people, whether they know about the RCM, or they already done the RCM, or they want to review the RCM analysis. Why I am telling you that it is very important, particularly in the refinery and petrochemicals, and in power industry, fertilizer industry, pharma, wherever you are. If you have RCM, it will give you a lot of benefits. There is no question about it. But to have a RCM analysis, you must not be convinced yourself. You have to convince your management, top management, because it entails money and energy, not of only yours but your colleagues. So it is a team phenomena. It is not that only you will do the RCM. So what is to be done regarding the RCM and why it is important? So I would like to tell you that each machinery, each equipment has some functions for the operations. For example, if you take pump or compressor, why I am taking the mainly equipment, two main equipment, because it is a well known in our industry. So compressors, whether it is a gas compressor or whether it is a air compressor, you need to supply gas or air on a particular pressure with expected consumptions capacity. So if you have a capacity of 10,000 meter cube per hour of any compressor, take it as simply this is a instrument air compressors related to for the production of the instrument air. Now already the capacity is fixed and the pressure is fixed. Maybe the pressure may be in the range of 7-8 kg per centimeter square gas. So now you have this function that this compressor should continuously supply 10,000 meter cube per hour on a 8 kg pressures. Now this is the main functions. This is the primary function, and secondary functions may be others, like you have this machine running without any problem, without any vibration, without any capacity restrictions, other things, other things are there. So that is, you can say, secondary functional problems. So mainly there are primary functions and secondary functions of any machines. So first part of the RCM is that you have to understand the functions in the operating context of that plant or that area. Second thing comes now the failures. Whether these functions are any failure is there for this function. I mean, compressor is having any problem, So we now troubleshoot the problem. Suppose the problem is in a lubrication, it may be operation problem, or you can say that temperature of the bearing is very high in the compressor. So now you have a problem. Although it is running, it is giving you the capacity, but now the temperature is high. That's why you are concerned about that, whether it will be running or not. So for that you already take the some, you can say, corrective actions. You see, inspect, and you troubleshoot whether some restriction in the cooling water or some restriction in the oil or something like that is there, and you bring it the temperature back. So this is what you generally do in the operations. But because of some reasons, suppose bearing is giving high temperatures and you don't know what to do, and it gets fails. So this is a failure. Once failure of the bearing is happening, it is a catastrophic failure. It can lead to another failure, like breakage of the casing or the shaft. Anything you can say can happen. So what I'm saying, that the failure is going to happen if you are not taking any proactive steps. So already you are taking the proactive steps, but there may be some situations where you don't have any corrective actions, and thus it will give some alarm, and the compressor will trip. In case suppose this protective function of alarm and trip is not working, you would not know the situation when the compressor is going in high temperature trip or high vibration, and it suddenly will fail. And it suddenly fails, what happens you don't know, and that is why it is a catastrophic failure. It can happen. We have given the protective systems that it should not happen, but it is not guaranteed that the protective systems also work all the time. So what I want to say, that there is a chances of failure. In the failure also, some are the potential failure. As I said, that if bearing temperature is getting higher, then there is a indication, there is a evidence. But in case the protective function is not working, for example, if alarm and trip is not working, this is a hidden. So there are two type of failures, what you call that functional failures, that sometimes it is evident and sometimes it is not evident. And how does it fail? What is the cause of the failure? That is known as a failure mode. So you have to identify for each machine the failure mode. RCM analysis is about the failure modes. Every machine has a typical failure modes. These failure modes in our operating context, the frequency of the failure may be less, frequency of the failure may be higher, but there is a cause for the every failure, and that is a failure mode. In failure mode, in terms of, you can also say these are the mechanism. Some failure is because of the age. You cannot run bearing more than 4 or 5 years, as you know, whether it is a pump bearing or any other bearing, the maximum life you will get the 4 or 5 years. So this is a because of the wear. But bearing can failure can bearing may fail premature because of any other reasons, like if you don't have the lubrication properly, or the fitting is proper, it is not proper, or other regions may be there, there's misalignment there, high vibration is there, vibration bearing noise is too much there because of the looseness or something like that, and the bearing will fail prematurely. So even after, even despite the age and something like that, the bearing may fail because of other reasons. So these are the failure modes, mechanism. Bearing is failing, that is a failure. Function, the machine is not working because of the bearing failure, that is a failure. You can say functional failure. Potential failure, when you know that it is going to fail because of the high temperature of the bearing, or whether it is a hidden or not, whether it is a failure of the protection or not. So once you know about the function of the machinery and the failures, you can know how many ways the machinery can fail. You cannot have the, you can say, motor not working or steam turbine not working, that's why it gets stopped, compressors or pump, whatever the your driven machine is there. So machinery is failing because of some failure mode. So you have to identify the failure mode. In your operating context, the failure modes, maybe some failure modes may be higher side. Suppose you have a lot of leakage in a steam turbine, so leakage failure is more. Or in case you have a vibration because you have not properly done the installation of the machine from the beginning, so you have a higher vibration always. Or you take the reciprocating compressor, you generally have the failure of the your suction discharge valve because of the leakage, the the gas, the recycling gas, the reciprocating compressor is compressing, is having the contamination, it has the leakage, so there are a number of failures of the valves, suction and discharge valves is more. So in your operating context, in your machinery, you must be having a peculiar, you can say, failure modes or failure causes. So identification of the failure modes and the frequency, it is a prime job in the RCM analysis. Once you know the failure modes, you might be having already place some maintenance strategies. In case of that the failure of the valves in the reciprocating is happening every 3 months or 6 months, so what you will do, you will replace the valve by taking the strategy of either preventive maintenance or predictive maintenance, or any other, you can say, strategy of replacement or whatever you want to do. So once you have the failure modes identified, you know what is the effect of the failure. Failure effects means when anything is failing, what is happening, whether you are getting valves damaged, or whether you have a safety valve failure, or anything components, mechanical seal, or any performance is deteriorated because of this failure. Maybe you having the vibration, or maybe having the less capacity, or maybe you are having the cavitation. So these are the failure modes. Or you have a heavy leakage, you have to stop the machine. These are the failure or modes have the effects. Effects means you have a final result, then you know the machine has failed. Now for every failure there is a consequences. Now consequences you can categorize in the terms of whether it is a safety hazard. For example, if you have a leakage of some toxic gas or hydrocarbons, it is a, you can say, potential hazard for any event, particularly safety related. It can, you can say, the operator surrounding there, if the toxic leakage is there, there is a hazard of that. It can lead to the death of the person, the operators or any other people. So you have to identify that if there is a leakage, there is a failure at the machine. Suppose compressor is failing without giving any alarm on trip, or you can say coupling has failed, and suddenly guard is not there and something happens. So I mean to say that failure can lead to some safety problem, or failure can lead to some environmental harm, maybe fire hazard may be there, or toxic leakage is there. When the toxic leakage is very heavy, the surrounding villages and surrounding people may get affected. So this event is environmentally affecting also, so the failure can lead to the environmental hazards. In a similar way, naturally the operation will be, for which the machine is there, mainly objective of the machine is that it should run safely without harming anyone and giving the production. In case of I taking the centrifugal compressor is giving you the instrument air, so it should give the instrument air of 10,000 meter cube per hour, or 7 kg or 8 kg per centimeter square gauge of the pressure. It should continuously, but if it is not giving, it is getting failed because of any failure mode, and the affected the machine getting stopped, you will have the consequences that your downstream plant where the instrument air is going, that is going to be affected. You have to shut down the plant or any other regions. So you might be having the losses, what you call the production losses or operation losses. So you have to categorize what are the consequences. because this consequences, determination of the consequences will determine your maintenance strategy. What is to be done to check the failure does not happen? What are the proactive actions you have to do? Generally already we are making maintenance strategy depending upon the criticality, depending upon the failure mode, that we have a preventive and predictive. So what the proactive action is there? It is a predictive or preventive maintenance. Predictive sometimes maintenance you call the condition based or online, or this is done through the condition monitoring. Now you have to fix the intervals. How would you fix the intervals? That you have to identify what type of failure mode is there, whether you can identify without the machine is failing. So potential failure you identify, and then you fix the intervals of monitoring half of the at least minimum potential failure. So suppose potential failure is 6 months, then you will give the monitoring 3 months. You might be having the already that you are going to have a practice of vibration taking through your portable meter every 1 month, every 15 days, or every 3 months, depending upon the criticality of machines. Also criticality of machines you categorize like ABC category, or viral, or you can say vital, essential, and critical. You might be having the CMMS, computerized maintenance management system, what you call SAP PM, where you keep all the data or everything related to the equipment. You might be having the failure history also. So what I would like to say that RCM analysis is mainly about the failure management analysis. So what are the failure causes? What is the history of your equipment of the failure? How your equipment in a particular industry, particular environment can fail in what manner? That is related about the failure modes. So it is about the functions and failures, failure modes, failure effects, and the failure consequences. Then what is to be done proactively, whether preventive or predictive? In some cases you are not having these functions technically feasible. You are okay, you said okay, we will do the vibration monitoring, or we will have a protection, protection protective instrumentations check every 6 months, to so that it doesn't happen, whether it is a hidden or evident. So in such a way that you are putting all the, or you already you might be doing very well. But what I'm saying that whether in the operating context, whether you have reviewed whether you are doing proper or not. For example, where preventive maintenance, you are checking the coupling or not every 6 months or every 1 year, or you don't need to, because you already have in place the vibration monitoring program. So vibration monitoring program already will give any problem related to the coupling, so it is not needed. In another case is, suppose if you have a number of pumps in the hydrocarbons, so then it is a criticality is different, and number of pumps in the supply of the water. So in case of the water, if something happens, something fail, it will not lead to safety hazard too much or environmental hazard, something like. But in the case of hydrogen, it is going to give. So a maintenance strategy, and you can say the type of procedures, functions, and manpower, training, and all those is are contributing what proactive action you are going to take, and whether it is a appropriate, and then what's doing. In some cases you are doing over too much preventive maintenance. You are replacing the spare parts, or refurbishment, or you are doing too much frequently, vibration management monitoring. Even you cannot manage the analysis, then but lot of data you are generating, and you are not using those data in preventing your failures. So all these things will come out in the RCM analysis, and it is a teamwork. Only RCM facilitator generally is taken from outside, but experience in your areas. RCM facilitator must be from that particular iron guide industry, at least if he is to do the RCM related to the machinery in the refinery or the petrochemical. In a similar case, for example, you can do some job in the power and utilities, because process industries less and more are same and the equipments less and more same, but failure modes will be different and the maintenance strategies will be different, the procedure will be different, the safety aspects and safety hazards and other hazards will be different depending upon the type of industry. So what I would like to say that it is directly linked what are your failure consequences when you want to have some maintenance strategy. Now once you know the maintenance history, once you know the what is the task is to be done, and how much interval you should have, whether it is a condition based or for the preventive maintenance, then you know whether it is a worth or not, whether it is a technically feasible or not. Only then you decide what is to be done to stop or check the failure. I would like to say again and emphasize that you cannot stop the failures and you should not be interested in stopping each and every failure. Depending upon the failure consequences, let the machine fail if it is not having a severe consequences, and you should not have the strategy stopping all the failures. Maybe that is a technically feasible but it is not worth doing. Now I come that there are many things you will get revealed, and I am certain I will tell you by my experience that in case you are doing the RCM analysis, I would say certainly you will have something where the machine is getting failed and you don't know what to do. In some cases, you have to take this is known as a default strategy. Strategy means whether you have to look into the design or alternate solution or some modifications, or you can say some totally different method for uh, purpose for which this machine has been taken. I will give you the one example that mostly for the air we are using the air blower in somewhere, some plant, this blower was getting failed and it was the screw type of blower. We were having the blower screw type of blower. So people have analyzed this and then they have decided, because in other cases they have seen the centrifugal compressor is better or centrifugal blower is better than this screw blower, so they replaced it and they had a lot of savings in the spare parts, and they have a lot of, you can say, saving in the headache and whatever others, unnecessary unwanted things were being done to maintain this blower. So in some cases, if you don't have the proactive actions which is technically feasible and worth doing, you can seek alternatives or modification. Another example I will give related to the lubrication system of a steam turbine. Here, we generally have the governor and MOP at the end of the shaft integrated, but this shaft was, this getting failed in a particular this joint where the MOP is located. So what the people have done, they said ki this MOP we should, in this case of the MOP, we should have a robust centrifugal pumps isolated from the steam turbine at another place, and let us not have this integrated MOP. So they have done the modification. I was part of it, that's why I am telling you, and we have reduced this problem of the failure of the MOP and governor which was running because of the end of the shaft. We were having the integrated small shaft for this purpose. So rather than having the MOP on the same shaft of the steam turbine, we had the MOP separately. So this was the alternate modification was done after, you can say, a lot of analysis. I'm not saying it is a part of RCM. What I'm saying that when you do the RCM, you will certainly have such type of solutions. So what is the RCM? RCM is a very wonderful. If you do the analysis, if you get nothing, at least you will get that your people get trained how should they look into the maintenance, and whether your maintenance strategies, whether your maintenance functions, whether they are really worth doing, whether they are technically okay or not. this insight you will certainly get. And I will say you should not go suddenly for all the whole complex. You may go for the one plant or two or three plants. If you are totally new to the RCM, if you are already practicing RCM, you are very much experienced people, you know a lot of things are there, then you can have the for the complex. But I would recommend that you must do it, because it is going to give you only benefit, no harm if you are not, if you are doing it. So what I would recommend, let us do the RCM analysis, whether you are a small plant or big plant, or you are having, you can say, a lot of decision making people there, what is to be done or what is not to be done. But yes, this RCM analysis will not give you immediate returns, you can say proven, you will not see, but in the process you will understand. And the process, when your people are engaged in this analysis, you will know that there is a lot of care. Thank you very much. If you have any question related to that, you can give the comments here, and I would like to have suggestions from you in what manner our these videos should be improved, so that I can communicate properly and it will benefit you. Thank you very much. Thanks a lot.